folks, let's see if we can roll through these Module Test 1 review problems. So the first one here, I have graph the equation using point-by-point plotting. In other words, do a t-table. Okay, now we have tricks for graphing, but when we first learn to graph, if we don't have any other tricks, the t-table is the way to go. Now, the hardest part about using a t-table really is just determining what to plug in. And with a square root, that can definitely be tricky. Now, some advice is if you're adding and subtracting underneath your square root to some variable x, find out what makes that equal to 0. Like if I substitute in 5 into that, that's going to give me the square root of 5 minus 5 is 0. So I highly suggest plugging in whatever value makes that equal to 0. Now, standard, we often plug in -2, -1, 0, 1, and 2 into any function, and we can try that out. But, you know, there's just certain things that help out a lot, and when you have a square root, plugging in whatever makes that equal to 0 is a really good idea. Now, maybe plug in some values around 5. Now, if I plug in, say, 6, notice I can't do that. So, let me show you why. You'd have the square root of 5 minus 6, which gives you the square root of -1, right? You can't have a negative under a square root and evaluate it and get a real number answer. So 6 is out. Oh, by the way, I never did plug in 5, did I? Let's do that. Square root of 5 minus 5 is the square root of 0, which is 0. We decided we can't plug in 6. The same thing is going to happen for 7, 8, 9, or 10. So let's plug in values less than 5, like say 4. That'd be the square root of 5 minus 4, which would be the square root of 1, which is 1. Or, for instance, 3. The square root of 5 minus 3 is the square root of 2. Now, the square root of 2 is not a nice number, but it's something you can certainly plug into your calculator and turn into a decimal, unlike the square root of a negative number, which is not real at all. Another good number might be 1. You know, you could plug in 2, but 1 gives you a nice answer. Square root of 5 minus 1 is the square root of 4, which is 2. Now, is that enough points to plot to get a shape? Well, you already have an idea what a square root graph looks like, don't you? We worked on those in section 1.6 in transformations. So right here, I'm going to plot the 0.50, okay, and the 0.41. 3, we'll do the best I can with 1.4, almost 1.5, and then 1, 2. And then you see that arc over shape. And I'm going to arc over to the left, and that's because of that negative in front of the x. But I wasn't asking you to look at this like a transformation. I was asking you to look at this more like just plugging in points. But you've got to be able to do that strategically. And when you have a square root, again, advice, just get the inside equal to 0 and then figure out what other points you can plug in nearby. Now we have a second graph the equation using point-by-point plotting. And again, so I'm going to draw ourselves a t-table. So I have a column for x and then a column for y equals x minus 2 squared plus 3, right? Just write the whole function down, or the equation in this case. Now again, good numbers to plug in might be -2, -1, 0, 1, and 2. That's not a bad idea. Now we do know the general shape of this. Remember, anything where you have your x squared as the highest power, that gives you a parabola shape. Not only that, using transformations, we know that this parabola is moved to the right 2 and up 3. So if we've moved to the right 2, then maybe we should plug in values around there, maybe like 0, 1, 2, 3, 4, something like that. Now, if you plugged in -1, or -2, -1, 0, 1, and 2, you would find out you only get the left side of the parabola, in which you need to plug in more values to get the whole parabola. But we know that if we transform this graph, we've moved to the right and we've moved up. Now, the up part doesn't affect what x values we plug in. The right part does, though. So if we've moved to the right, let's pick some values on the right, like we did, 0, 1, 2, 3, and 4. Now I'm going to plug those in. So that's going to be 0 minus 2 squared, and then I'm going to add 3. So that's going to give me -2 squared, which is 4 plus 3 is 7. So 0, 7. And then 1 minus 2 squared plus 3. And 1 minus 2 is -1 squared plus 3 is 4. Now 2 minus 2 squared plus 3. 2 minus 2 is 0 squared plus 3 is 3. 3 minus 2 squared plus 3 is 1 squared plus 3. I square that 1 is 1 plus 3 is 3. And 4 minus 2 squared plus 3. I do 4 minus 2 is 2 squared plus 3. I square my 2. That gives me 4 plus 3, which is 7. That's fast. Slow it down. Pause it. Do it on your own to make sure you get those same values. Now, when I plot these points, I've got a 0, 7. I've got 1, 4, 2, 3, and then 3 is 3, and that's not right. I've got a mistake. Let me plug in my 2. That's right. Yeah, that's 4, y'all. And you probably caught that, but I just did. So 3, 4, and finally 4, 7. There we go. We connect those dots, and that's that parabola shape that we were expecting. It goes up and to the right forever, and left and up forever also. All right, now we have a different type of problem. Problems 3 through 8, I asked, do the following sets or graphs or equations define functions? And that's really 3 different types of problems answering the same question. And these are sets. These are sets of ordered pairs. And remember, to define a function, you know, for each input, or for each x, there's only one y. And that's what we have to look at. So our x's in problem number 3 are -1, 0, 1, 2, and 3. They all vary. -1 only gives you one answer, and that happens to be 2. 0 only gives you one result, that happens to be 2 also. Doesn't matter that those 2's match. Where it goes wrong is if the x's match, but none of these x's match. Therefore, for each x, you only get one y. So yes, this is a function. And again, if I have to explain why, this is why. For each x, there's only one y. On the other hand, when we look at -1, 2, -1, 3, 0, 2, 0, 3, that's definitely a relation. It's a set of ordered pairs. The problem is, for x equals -1, I've got 2 different y answers. I've got 2 and 3. And it is a relation, but it is not a function. You also might have noticed that for x equals 0, you also get 2 different y values. But it only has to go wrong one time. I made this particular one go wrong in 2 different ways. But this is enough to say that number 4 is not a function. Whereas number 3 is a function because the x's do not repeat. For each x, you only get one y. Now, continuing with the same question, do the following sets, graphs, or equations define functions? And for problem number 5, it's the graph of any circle, right? So if I just draw a random circle, I know that's not a perfect circle, but it doesn't matter, right? Then that does not represent a function. Why is that not a function? Well, you have to be able to say why it's not a function. Well, one reason is for this particular x right here, no matter what it is, I have 2 different y values. Look, that y value and that y value both go with that particular x value. Now, you could say that it fails the vertical line test is probably the easiest way to answer that question. So no, it's not a function. Why? Because it fails the vertical line test. But all the vertical line test is a test to see if for a particular x, there's more than one y. Now, number 6, same thing. We could do the vertical line test on here. So, you know, picture a spaghetti noodle in your hand and just slide it up and down across. And no matter where you slide it, you can even envision all these little index lines, these vertical lines, only intersect your graph just one time. Like it only intersects there. Or that one only intersects there, or this one over here only intersects there. There's no way a vertical line is going to intersect this graph more than one time. So the answer is this is yes. Number 6 is a function, and that's because it passes the vertical line test. I'm putting VLT since I've already spelled it one time. Okay? Now here we go again with the same question. But this time I give you an equation. Does the equation define a function? Now, one thing you could do is you could graph y equals x squared minus 2x minus 1, or the second one, x squared plus y squared equals 16. But that's not what I had in mind. What you should do when you're given an equation is solve for y. So get the y by itself, okay? If there is no plus or minus, if you don't have, when you solve it, if you don't end up with a plus or minus in your answer, then it's a function. Look, this one's already solved for y. There is no plus, I don't mean a separate subtraction and addition. You know what I mean? Like when you have plus or minus the square root. If you have that situation, this is not a function. There is no plus or minus over here. Okay, this is just a simple polynomial. There's no, plus x squared minus 2x plus 1 and then a negative x squared minus 2x plus 1. There's not that. So this is a function. This is a yes. On the other hand, the second guy right here, we got a problem. When we solve this for y, the first thing we need to do is subtract the x squared over. It gives me y squared is equal to 16 minus x squared, or if you'd rather, you can write that as negative x squared plus 16. Doesn't matter. Then I take the square root of both sides. So I have the square root of the left, the square root of the right. Well, when you use the square root as a tool yourself, you must put the plus or minus. Now, the square root and the square cancel each other right there, but I have two separate answers. One's positive square root of 16 minus x squared. The other is negative. And again, that means we do not have a function. This is not a function. And just FYI, and we're going to learn this later, that's a circle with radius 4. We already talked about circles. Now, that's not something you're supposed to know yet because we're doing this algebraically and not graphically when we're working with these two equations. But that is a circle, so it would fail the vertical line test. All right, here's a different kind of question. Find the x-intercepts, y-intercepts, domain, range, and intervals of increasing, decreasing, constant for the following graph. We've got a lot to find. So x-intercepts. X-intercepts are defined to be where the graph crosses the x-axis. Okay? Now, I would like those in point form. If you're doing these in the homework, they might accept 2 and 4. But really, that's a point, and that point is 2, 0. And the other point is 4, 0. It's not the 0.24. Y'all, the 0.24 is way up here, not even on the graph. Those don't go together. They are two separate x-intercepts. Okay? Now, the y-intercept, that's the next question in line. Again, it's a point. Now, it's down here. Looks right there. It appears to be 0, negative 8? So, negative 6, negative 7, yes, 0, negative 8. Now, again, in the homework, you might get away with typing in negative 8 for the y value, but I really want it in point form. Now, the domain are the values from left to right for which this graph covers. Notice the arrows at the end. The graph continues on forever. Even if those arrows weren't there, we would assume it continues on forever unless we see a starting point. So you should assume that anyway. Now, this goes from negative infinity to positive infinity. We're not talking low to high. We're talking left to right. So the domain is negative infinity to infinity. Now the range, though, on the other hand, see, these are x values only. The range, on the other hand, is y values, okay? The low, they go down forever, so this is negative infinity. But look, it goes up to y equals 1, which is that point right there, and stops. So I put a bracket because that is included. Now, increasing, when we talk about intervals of increasing, we're talking about where's the graph rising from left to right. If I highlight that for you, that's this part. Notice that is going up from left to right. It looks like it's going down, but you're reading it backwards. If you don't look at the arrows on the end, read it from left to right, and that is rising from left to right. Now, when you do increasing, decreasing, and constant, you only consider x values. So, again, for your notes, only x's. Okay, so we're going from negative infinity all the way to this x value right here, and that x value is 3. Parentheses. Another thing you do for increasing, decreasing, and constant is you don't include the endpoints, because think about it. You're not increasing at 3. You have stopped increasing at 3, and you start decreasing at 3, and you can't be increasing and decreasing in the same location. So next is decreasing. Again, x values only when you answer this question. So where's my graph decreasing? If I highlight this for you, it begins right here, and all that part is decreasing when you look at that from left to right. So it begins decreasing at 3. Again, I don't include the 3 because for increasing, decreasing, constant, you don't include. How far to the right does it continue to decrease? Infinity. And I think that's all I asked. Yes, that's all I asked on that one. Now here's our big fun problems, okay? So domain, when I look at this graph, again, notice the arrows on each end. That does mean it continues forever in both directions. If you don't see arrows, but it looks like it still goes on forever, then it does. You have to have a place where you know it absolutely starts otherwise. But this continues forever in both directions. Notice over here, it goes up forever, and it goes to the right forever. That's what that means. It's not completely vertical. And on this side, it goes to the left forever and down forever. Because again, that line is not completely vertical. So what does that mean? The domain is negative infinity to infinity. Remember, that's my left to right. The range low to high is also negative infinity to infinity. Intervals of increasing. Let me highlight that in blue for you. That's where the graph is rising from left to right. Look, all of that is rising from left to right. Is that the only place? No. Right there, I'm also rising from left to right. But increasing, you're only supposed to include x values. That's true for decreasing and constant. And the x values where this is rising is negative infinity all the way to, now careful here, that x value is not 6. That x value is 0. Matter of fact, that point right there is 0, 6. You may want to label it. This point over here is kind of important too, although harder to see. So that's 1, 2, 3. So let's call that 2.5, negative 1. That negative 1 I'm rounding a little bit. Doesn't look like it goes quite that low, but it says approximate any answers that are integers to the nearest whole number. But I'm going to keep that 2.5 because I don't really want to round that. Are you with me? Okay. So I did my directions slightly different than what I really mean. I may go back and change those directions a little bit. But, so here we go. Increasing. The first blue from the left is negative infinity to 0. Okay, now I'm used to using a union symbol right here. In the homework, they just use a comma. I will take either one. That second piece is from 2.5 or 2.5 to infinity. Again, notice that's 1, 2, but it doesn't go all the way over to 3, and that's why I called that 2.5. We just have to approximate, and it's almost negative 1 is the y, but we're not answering y questions right now, okay? Just x questions. Intervals of decreasing, that's that piece in the middle. So this is falling from left to right. Again, I only use the x values. You got to stop yourself every time and remind yourself you're only using x values when you answer these 3 questions. So x values 0 to 2.5, and that is the only interval of decreasing. Okay, and again, I'm not going to approximate integers to I can't say it. Approximate to integers for the nearest whole number because I just don't want to. I'm going to leave that as 2.5. But on the test, I'll make sure they're nice whole numbers for you, okay? X-intercepts, this is where the graph crosses the x-axis, right? Now, I'm going to erase a little bit. So, there we go, okay? Now, let's look clearly and see where the graph crosses the x-axis, okay? So, right here, that green is an x-intercept, there's an x-intercept, and there's an x-intercept. Now, you can just write the x values. Maybe in their homework it accepts that, but I want it in point form. So negative 1, 0 is the one on the left. The next one I see is 2, 0. And then the one on the far right is 1, 2, 3, 0. Y-intercepts, that's where the graph crosses the y-axis. We already have it labeled as up there at 0, 6. And it only has one. Matter of fact, functions only have a single y-intercept or no y-intercept at all. You could have a graph that doesn't have one at all. Relative maximums, remember those are mountains you can hike up and over, or hills if that makes you feel better. I asked for that as an ordered pair, 0, 6. Now in your homework it might ask where it happens. That would be at 0. It asks what the maximum is. That would be 6. Relative minimum. That's going to be your valley. But now if you have a low point, you have to be able to hike back up the other side. So our valley is that guy we approximated at 2.5, negative 1. Now this is a fun question, and I don't know if you've run into this in the homework, but it's something I want to point out. It's kind of above and beyond, but it's interesting to look at. Now, when I ask about f of x is greater than or equal to 0, Now remember, f of x is a y value, right? So this is no different, y'all, than saying y is greater than or equal to 0. So I'm looking at my graph, and I'm going to highlight everywhere y is greater than or equal to 0. So all this stuff is above the x-axis, so all those y's are positive. And look, all those y's are positive also. The bottom of our hump here, those y's are negative, and then below over here, those y's are negative. So it wants to know all the values. Now, I can't list them, right, because it's an interval. So I have to answer this in interval notation. So it begins at this x value, which is -1. Okay. Now, do I include it? Yeah, because it said greater than or equal to 0. And then it stays above all the way until we get to 2. I also include it because it's equal to 0. Where else? It starts over here at 3. And it goes again. 3, when do I stop? Infinity. Interesting, huh? All right, next question. Very similar question. It asks all the values for which f of x is less than, not less than or equal to, less than 0. Now that's this interval here that I'm doing in blue, and then this interval here that I did in blue. Now I'm only answering the x's. I'm going to pick a different color so it's not so clustered up. There we go. Now, these x's right here are negative infinity all the way to -1. But you know what? I don't include the -1. Why? Because it says less than 0. At -1, it's equal to 0. And then this little bitty blue piece right here that dips down below the x-axis is going from 2 to 3. So that little bitty interval from 2 to 3. Again, I use parentheses because it said where is it less than 0. And that doesn't include at 2 and at 3. Finally, k, what about where it's equal to 0? Well, you know what? Those are exactly the same values as the x-intercept. So it's equal to 0 at -1, +2, and +3. So it's x equals -1, +2, +3. I don't write those in point forms because it just wants to know the x values where the y value is equal to 0. Now I'm on question L. And question L says find f of 0. Now, I'm going to erase again, y'all, so I can get rid of all of this information. All right? And it wants to know what is f of 0. Remember, that's the same thing as asking when x is equal to 0, what's my y value? Okay? Well, right here, when x is equal to 0, my y value is 6. So that answer is 6. The second question, M, is asking the same thing, but this time it's saying when x is equal to 1, what's my y value? So I go over here to x equals 1. I go meet the graph. What's that y value? 4. So f of 0 is equal to 6. F of 1 is equal to 4. Now, question end, values for which f of x is equal to 10. So that's backwards. That's asking when y is 10, what is x? So I need to go up to y equals 10. So right here at the very top of my graph, I don't go down because y equals 10 is that horizontal line. Y'all, that's that point right there. And I got to think backwards. That is x is equal to 4. Gives me y is equal to 10. Ooh, y'all, my PowerPoint just flaked out on me. I'm sorry about that. That probably looked weird. But anyway, so right here we've got y equals 10. What is x equal to? X is equal to, we decided that was 4, right? Well, we were thinking backwards. Uh-oh. Now my pen's not working. It's all falling apart. Hold on. There it is. X equals to 4. Okay. Moved my page all around, but we're all right. Is this a function? Yup. Why do we know this is a function? It passes the vertical line test yet, right? So yes, down here in question O, it passes the vertical line test. Sorry for the tiny. Does this graph represent an even, odd, or neither equation? Neither. Remember, an even function is a reflection around the y-axis. So it would have to be like a butterfly. It'd have to be the same on the right side as on the left side. That's not the case. Odd is not reflection around the x-axis. Odd means you can rotate the first quadrant to match the third quadrant and simultaneously rotate quadrant 2 to match quadrant 4. Or You can fold it along the y-axis like a piece of paper and then fold again along the x-axis and everything line up. And that's definitely not the case in this particular problem. So no, this has, it's not even, it's not odd. So that only leaves neither for this particular graph. Okay, so let's see if we can do number 11. Very similar problem, just a crazy looking graph, right? The domain, remember, is left to right. Now look at the bottom left over here. That graph literally starts at whatever that point is. And you can see that that point is -5, -10. The graph literally starts there. And then it just looks like a, you know, a weird looking zigzag, right? It goes up and then flattens out, and goes up and flattens out. So where does it stop? Well, it doesn't. There's an arrow over there. It goes to the right forever. So I can't label any points where it stops. But it literally starts at -5, -10. So the domain is going to be -5 with a bracket all the way to positive infinity on the right. The range, low to high, the lowest it goes is -10. So once again, I'm going to have a bracket, -10, not a parentheses, but a bracket. Now, it doesn't go up forever, right? It goes up to 2. That horizontal line right there is at 2. And it stops. So I include the 2. It doesn't go higher, any higher than 2 because that's constant over there. Intervals of increasing. Let's highlight increasing. So that little segment right there is increasing, and this segment right here is increasing. Remember, when we do increasing, decreasing, constant, we only use x values. So I start increasing at -5. I always use parentheses. And then it stops at this point right here, which is x is equal to -1. But then it starts again over here at x equals 1, 2, 3. That x value is 3. And it stops at x equals 5. That is not a 5. That is a 5. Okay? So again, if you need help labeling this point right here is -1, -2. This point right here is 3, -2. And this point right here is 5, 2. So we went from -5 to -1, and then we went from 3 to 5. And your left number should always be smaller than your right number. Decreasing. Let's do this in green, and I'm going to highlight for you in maybe yellow. So nowhere. Look, I'm not decreasing anywhere, so that means I leave it blank, right? No. Please don't leave it blank. You got to tell me that it's not decreasing anywhere. So you could say none or nowhere. Just let me know. Even the empty set tells me it's not decreasing anywhere. You know what I forgot to ask? And I definitely should ask, and I'm going to add this to your study guide or your list of questions, but constant. Where is this graph constant? And I should have asked it on the last graph too. In the last graph, it wasn't constant anywhere. This one is constant between -1 and 3. And then starting at 5, where does it stop? It doesn't, okay? So I'm going to put this as NOPQ, question Q. Where is it constant? And I'll do that on the last graph too. I just forgot to ask it before I started making the video. So I'll fix your handouts, okay? X-Intercept. The X-Intercepts, where are they? There's only one. And I see it, and it's right over here. Notice that point is the point 40. Remember, x-intercepts need to be 0.4, 40. Y-intercept sure is right there. So 0, -2. Relative maximum. You know what? I don't have one. And you're thinking, yeah, there's a high point right there, but there's not a high point. There's a whole high interval, which doesn't count. So remember, a maximum's like a hill or a mountain you have to be able to hike over. It's got to be one point at the top and go back down. So there is no maximum and there is no minimum in this case for the same reason. Find all values for which f of x is greater than or equal to 0. That means the y is above the x-axis. Y'all, I'm going to highlight it in yellow over here. That yellow part, which now is green and yellow, is the only part above the x-axis. That means y is greater than or equal to 0. That's another way of saying that, and that only happens from 4 with a bracket to infinity. What about f of x is less than 0? Okay, if I erase, let me just erase a lot of this. If I erase and highlight that for you, less than 0 is to right there. All that highlighted is less than 0. Okay, so that means all that is below the x-axis, which means really y is less than 0. It's just another way of saying that. And that's going to be my x values from -5. Okay, I'm just using x values, right, because that's what it asked for. -5 with a bracket, because that point's included, all the way to 4. But you know what? 4 is not included because it strictly said just less than 0. And then it asked for where's f of x equal to 0. That's that point we labeled just a minute ago. It's the same as the x-intercept, and that is at x equals 4. F of 0 is when you plug 0 in for your x value and you get -2 for your y value. What's f of 30? Now your first thought might, well, there's not a 30 on the graph, but there is way out to the right over here, right? This arrow tells you that this pattern continues indefinitely. Okay, it goes on forever. So even at 30 or 3,000 or 3 million or 3 gazillion, my y value is at 2. Now, if it weren't constant, I couldn't tell you that. But since that's constant going to the right forever, I know my answer is 2. Also says in values for which f of x is equal to -8. So I'm going to erase again. And I'm going to go to y equals -8, because that's the same thing as what f of x equals -8 means. Here's -8 right down here, and I'm going to go meet the graph. So I'm going to go over and meet the graph, and I'm going to make a point there in blue. There it is. Y'all, what's that x value? Well, if I back up, that's -4. So x equals -4. Is this a function? Yes, it is. It passes the vertical line test. So VLT, because I'm out of space. Does this graph represent an even, odd, or neither? Y'all, none of those. This is an even, odd, or neither. There is no reflection down the y-axis where you fold it and it lands on each side. There is no rotating the first quadrant to the third quadrant. This up here doesn't match this down here. Nope. Nope. No symmetry at all in this particular situation, although it's an interesting graph. Okay, so I'm going to stop the video here and then pick up another video to start explaining problems 12 on. Y'all have a good one.